Good afternoon, everyone. Today, I'll be discussing linear programming problem using graphical method in solving maximization problem. Let's have this example. Pineda Limited makes two products, tables and chairs, which must be processed through assembly and finishing department. Assembly has 60 hours of available work time, while finishing can handle up to 48 hours of work. Manufacturing one table requires 4 hours of assembly and 2 hours finishing. Each chair requires 2 hours in assembly and 4 hours in finishing. If profit is 800 per table and 600 per chair, you have to determine the best possible combination of tables and chairs to be produced in order to maximize profit. Okay. So, the first step in all the problem is write down the given. We have to identify also the decision variables. So, the variables that we are looking for. In this example, we need to know the number of chairs and tables to be produced to be able to maximize profit. That's why we're going to assume that x1 will be the number of tables to be produced and x2 will be the number of chairs to be produced. And since this is maximization, so we're going to compute also the maximum profit. Okay. So as mentioned in the given, so we have x1 and x2 and the total number of hours available. For the assembly, as mentioned in the problem again, it requires 4 hours. For every tables, 4 hours, and for every chairs is 2 hours. Same thing with the finishing. Each table requires 2 hours and 4 hours in each chair. Okay, so it was also mentioned the total number of hours available for the assembly is not more than 60 hours. The same thing with finishing, it's only 48 hours. And the profit is 800 per table that they produce and 600 for chairs. So from the given, we'll be able to write down or formulate the LP model. So the objective function is again maximization. So we're going to compute the total profit, which is equal to 800 x1 plus 600 x2. Subject to the following constraints, we have the assembly and finishing. For the assembly, as seen in the given, we have 4x1 plus 2x2 is less than or equal to 60. And for finishing, it's 2x1 plus 4x2 is less than or equal to 48 hours. And of course, do not forget to write down the non-negativity constraint, which is your x1 and x2 should be greater than or equal to 0. The next step will be plotting the constraints. So we do have two constraints. The first one is the assembly, wherein the equation is 4x1 plus 2x2 is less than or equal to 60. So for us to be able to plot it in the Cartesian plane, we need to assume that one variable is equal to 0. So if x1 is equal to 0, your x2 will be equal to 30. And if x2 is equal to 0, your x1 is equal to 15. The same thing with finishing. So we have the equation and we assume one variable is equal to 0. So if x1 is equal to 0, your x2 is 12. And if x2 is equal to 0, your x1 is 24. So if you're going to plot it in the first quadrant of Cartesian plane, this is what it will look like. So as you can see, the two constraints is already written or plotted. Okay? So, if we try to remember the procedure or the step-by-step solution on how are we going to compute the maximum or optimum variables, all the constraints should be met. So in this example, it's less than or equal to, that's why the shaded area for 2x1 plus 4x2 is less than 48 is this. The same manner, for the equation 4x1 plus 2x2 is less than or equal to 60, the shaded parts are this. So if we're going to compute or to shade the feasible area will be from here, going here, and here. So this is your feasible area. Feasible area. And from that feasible area, you'll be able to see the corner points. We have A, B, and C. For A, the value of x1 is already given. So x1 is equal to 15 and we don't have any value for x2. That's why if we substitute it from the profit formula that we have, in point A, the total profit is 12,000. In point B, we have an intersection. That's why using elimination, we'll be able to know the value of x1, which is equal to 12, and the value of x2, which is equal to 6. So if we substitute it from the profit formula, in point B, we will have a profit of 13,200. And in point C, as seen in the drawing, your x2 value is equal to 12. That's why if we substitute it, and we don't have any value with x1, so if we substitute it with the profit formula, the total profit in point C is 7,200. So among the 3 points, we will choose the highest profit. So in this problem, the highest will be in point B. Why? Because in point A, it's only 12,000. In point C, it's only 7,200. Whereas in point B, the total profit is 13,200. So meaning, the optimum value of your x1 and x2 is 12 and 6. So the decision will be to produce 12 tables and 6 chairs to get the maximum profit of 13,200. That ends my lecture. Thank you.